Today I would like to introduce the dynamic technology coolStep. coolStep is a technology to regulate the current of a stepper motor according to the load without using any sensors. That leads us to the major problem with in the use of stepper motors, which is stepper motors are usually inefficient, need a lot of power for safety margins, and you have to always dimension the current much higher than you actually need, because you have to avoid step loss if you have a torque peak. Dynamic has developed technology that we call coolStep, which is implemented in our newest generation of stepper motor driver ICs. And with me today is Dr. Larsson. Lars is one of the co-founders of Dynamic Motion Control and one of our senior IC developers. He was involved in the development of this coolStep technology, and Lars will explain a little bit about the technology and how it works and show the effect.
Yeah, thank you. So currently the motor is running with a low current, and if I apply load on the motor, then the chip detects the load sensorless and increases the current. Now the motor runs with a full current. When I remove the load, then the chip reduces the current, and this saves much energy. So the torque of a motor is proportional to the current, and the power dissipation is proportional to the square of the current. So if I halve the current, I quarter the power dissipation. One thing is the sensorless detection of load. So it bases on the technology Proeger. So first thing is to detect sensorless load on the motor with the Proeger feature, and then when the load is detected, the current is enhanced immediately, because we don't want to change the dynamics of the stepper motor. So when I apply the load, the current is enhanced and it slowly decreases. Why does it slowly decrease? Just to avoid regulation oscillations. So with this technology, one does not get oscillations due to regulations, and one has the same behavior of the motor as a standard stepper motor, but with a quarter of the power dissipation.
I don't know, Lars, did you mention that this also enables temporary overloading of the motor?
No, not yet.
This is quite a nice feature that you can basically, if a motor is terminally limited with regard to current, then it's possible to overdrive it for a short time period. So the current will immediately go up, and let's say to 120%, which gives you a certain amount of extra torque for a short moment. Yeah. And that's pretty nice, so it might save you a lot of money if you are able to choose a shorter or even a smaller motor with regard to the NEMA size. Okay.
This technology is completely included in the chip, so you will not have to do this in a microcontroller and have to do the calculations yourself or program the calculations. It is completely included in the chip, so it can react very fast. The current increase can be done within one full step. So it keeps the load on the MCU low, and you still have the energy saving.